Hi everybody, in this video we're going to go over the check your understanding for triangle segments and centers. So the first page has a review of what the 4 different triangle centers are, so definitely take a look and read through. I'm going to skip right to the questions so that we can start going over them on this video. So the first part is matching. We're going to match the triangle center to its definition. So the point where all the altitudes meet, if you refer back to slide 1 or your graphic organizer from class, that would be the orthocenter. So that is B. The point where all the medians meet, that is the centroid. The point where all the angle bisectors meet, that is the incenter. And the point where all the perpendicular bisectors meet, that is the circumcenter. Point Z is the centroid. So based on the first part, the centroid is where the medians meet. So Z is the centroid. It's where the medians of this triangle meet. We're told that ZF is 5. AD is 12. Let me use a different color for AD. And BC is 18. What is the perimeter of triangle DCZ? DCZ. So this is the triangle that I am trying to find the perimeter of. So in order to find the perimeter of this triangle, I see that I have ZF, which is the shorter part of this whole median over here. So I know that the centroid splits each median in a 2:1 ratio. So if ZF is the shorter part of the median, that's the 1 part of the ratio. So the 2 part of the ratio would be 10. I know that AD, the entire median over here, is 12. So once again, I know that the 2 parts of the median are split in a 2:1 ratio. The smaller part and the smaller part and the larger part are in a 2:1 ratio. So the larger part, the 2x part of the ratio, plus the smaller part, the 1x part of the ratio, is equal to the whole median, which is 12. Solving real quick. I find that the 1x part of the median is 4. And that makes sense because then the longer part would be double that. It would be 8, and together 4 plus 8 makes 12. So that makes sense. And then finally, to find the perimeter of this triangle, now I have 2 sides. I just need this last one, DC. So we know that the whole side of the big triangle is 18. BC is 18. And since a median connects to the midpoint of the sides, we do know that the side is being split in half by the median, because that's the midpoint of the line segment if this is the median. So if the whole thing is 18, each half would be 9. So we have the 3 sides, 9 plus 10 plus 4, 23 is the perimeter of triangle DCZ. Which type of triangle would have its orthocenter on the triangle? We talked about that in class. That would be a right triangle. A right triangle has its orthocenter and circumcenter located on the triangle. Which of the 4 centers always remain on or inside the triangle? So always means that in every situation, on or inside the triangle. So remember that in an obtuse triangle, the orthocenter and circumcenter are actually located outside the triangle, as we saw from our constructions and talked about in class. So the ones that always remain inside, on or inside the triangle, are the ones that are not orthocenter and circumcenter. The two that are always inside the triangle are incenter and centroid. So that is B. Now for the medium section. We have triangle ABC. Jose found centroid P. So once again, we have a centroid. So that means that the segments forming the centroid are medians. And we need to remember our 2-to-1 ratio that the centroid splits each of the medians into. The longer part's the 2 part of the ratio, the shorter part of the median is the 1 part of the ratio. He measured and found it to be 6 inches. So that wording here, and I'll fix it on the actual document, so by the time you watch this video, it'll probably be fixed. It's a little weirdly worded. So he measured what and found it to be 6 inches. So I'm guessing he measured median CF. So I'm going to put that here. He measured median CF and found it to be 6 inches. So this whole median here is 6 inches. If PF is X, which equation can be used to find X? Well, remember, the centroid splits each median in a 2-to-1 ratio. The longer part's the 2 part of the ratio. The shorter part is the 1 part of the ratio. If the whole thing equals to 6, we know that the 2 part of the ratio and the 1 part of the ratio together make 6. There we go. Given that point S is the incenter of a right triangle PQR, so incenter, that's where the angle bisectors meet. So I know that these are angle bisectors, these segments, because this is the incenter. So I know that it is splitting the angles in half, because an angle bisector cuts an angle in half. So already I know that the 90-degree angle is being split in half. And I know that the 30-degree angle is 2 equal parts. So I just filled that in. What are the measures of angle RSQ? So RSQ is this angle right over here, RSQ. So that is the third interior angle of the triangle that I highlighted in blue. So all 3 angles of any triangle add to 180. So if I do 45 plus 30, that is 75. And then if I subtract that from 180, I get the measurement of the missing angle. So angle RSQ is equal to 105 degrees. And we also need RPQ. So if we take a look at the whole big triangle, once again, all 3 interior angles should add up to 180. We already knew that this angle here was 90. And we know that this angle, so this angle in the triangle is 90. This angle is 60. 30 plus 30 makes 60. 90 plus 60 is 150. And then if we subtract 150 from 180, we get the remaining angle in the triangle. So angle RPQ is equal to 30 degrees. For the questions below, identify the given segment as a perpendicular bisector, angle bisector, median, or altitude. So AF is congruent to FC. Remember to always mark your diagram with the givens in any way that makes it easy for you to see. Angle ABE. So that's all the way from A up until E. I don't want to get F in there by accident because that's going to confuse me. So just until E. There we go. And that's congruent to angle EBC. There. I just want to be able to differentiate between the two. They're both congruent. Angle ABE is congruent to angle EBC, all the way from E up to B down to C, this whole part over here. So already I can tell that if AC is being split into two equal parts at point F, then point F is the midpoint of AC. Remember, if we have two congruent parts, that tells us that this is the halfway point, so that's the midpoint. I also see here that the whole angle B, I'll call it angle ABC, that angle ABC is being bisected. We have two equal parts, so it is being cut in half. And since one equal part is from A to B to E, and the other equal part is from E to B to C, E from B to E is where it's being cut in half. So I'm going to write here, BE is bisecting the angle. And I'll draw it into the diagram so you can see that clearly. If I draw from B, let me use a line because I want that to not go 50 million other places. Oops. There we go. BE is where our angle is being cut in half. That is where the congruent pieces meet. That is where the two angles are being split in half. At BE is doing that to the angles. So I see that we've already answered what BE is just from looking at the diagram and drawing conclusions from our givens. BE is an angle bisector. Let's take a look at the rest. Let's take a look at BF. BF, let me draw another line from B to F. I'll use red. So from B to F, so we can see it clearly. So B is a vertex of the triangle, and it's being connected to the midpoint of the opposite side. Medians connect midpoint to opposite vertex. So it looks like BF is a median. BD. Let me get my line so I can draw this in nicely. So from B to D, well, it doesn't go to a midpoint, but I see that where BD meets the side of the triangle, it makes a right angle. It's a perpendicular line. Remember, altitudes are perpendicular lines that pass through the opposite vertex, and this perpendicular line does pass through the opposite vertex. So let me write that down. This is an altitude. And finally, GF Oops. So GF, I see the right angle where it meets the side of the triangle, so it's perpendicular to the side of the triangle. And remember, we also said how F was the midpoint of the side of the triangle because it's where it's being cut into two equal parts. So not only does the segment form a right angle, not only is it perpendicular, but it also passes through the midpoint. It also bisects the line segment. So here we have a perpendicular bisector. It does two things. It forms a right angle, and it also cuts the side in half. Perpendicular bisector. Okay, moving on. Okay, so we were told that we have medians in the diagram. So if we have medians, the point where they intersect is called the centroid. And remember, the centroid splits each of the three medians in a 2-to-1 ratio. That comes up a lot, so you definitely need to know that 2-to-1 ratio whenever you see where the medians intersect or whenever you see the word centroid. If FB is 39, find BG. So remember, the median is split in a 2-to-1 ratio. So here the 2 part of the ratio and the 1 part of the ratio together make the whole median, which is 39. Oh, we were looking for the larger part. I almost got confused here. The smaller part, x is 13. That means the larger part of the median is double that, 26. And it makes sense because 26 plus 13 gives us the whole median, 39. I'm going to reset for the next part of the question. Okay. If EC is 17/6, find BC. Well, I know if the segment is a median, because all of these segments are medians, it connects midpoint to opposite vertex. So this is the midpoint of the side. So I know that this is equal to it because midpoints split a side equally in half. So the whole thing BC would be 17/6 plus 17/6. And that would be 34/6. That doesn't divide evenly, so I am just going to leave it as 34/6. You can definitely reduce the fraction into simplest terms. I'm going to leave it as is. It doesn't say simplest form. Let me reset for the next part of the question. If DG is 4 radical 3, find CD. So DG is the 1 part of the ratio. CG is the longer part of the median, so that's the 2 part of the ratio. So the 1 part of the ratio, if we double it, we get the 2 part of the ratio. That gives me 8 radical 3. Remember, multiply coefficients. So we have 8 radical 3 for the 2 part of the ratio, 4 radical 3 for the 1 part of the ratio. Adding them together, we get 12 radical 3. Add the coefficients. Let me reset for the next part. If AF is 2x plus 4 and AC is 3x plus 13, find FC. So I know that we have medians here, and medians connect midpoint to opposite vertex. So this would be the midpoint of side AC, which splits it into two equal or congruent parts. So if this is 2x plus 4, this part is also 2x plus 4. So we have 2x plus 4 plus 2x plus 4 equals 3x plus 13. 4x plus 8 equals to 3x plus 13. Really quickly solving, we have x is equal to, subtract 8, 5. Now let me plug in our x value for FC to find out what it is. 5 times 2 is 10, plus 4 is 14. And this side is also 14. If DG is 4y, CG is 20, find y. So the 20 is the 2 part of the ratio. It's the longer part of the median. And the 4y is the 1 part of the ratio. It's the shorter part of the median. So I know that if I take the shorter part of the median and I double it because it's a 2-to-1 ratio, I get the longer part of the median because this is double that. 8y is equal to 20. Y is equal to 20 over 8. Doesn't go evenly, but I can reduce. I'm going to divide top and bottom by 4, and I get 5 over 2. And it just asked us to find y. It didn't ask us to plug back in. Okay, last question. The angle bisectors of triangle ABC meet at point G. So point G is the in-center. That is the triangle center where all of the angle bisectors meet. So I know that these segments here, and let me just erase my marking there to avoid confusion, but all these lines here, these angle bisectors, are cutting each of the angles in half. So I'm going to mark that. This angle bisector is cutting this angle in half. This angle bisector is cutting this angle of the triangle in half. And this angle bisector is cutting this angle of the triangle in half. So we have GF is 120. AG is 130. Find DG and AC. So this one's a little bit more difficult than what we're going to see on a test coming up. But a fun fact about the in-center is that it is equal distant from the sides of the triangle. So the shortest, the way to measure distance and equal distance is with an altitude or a right angle. So what we really have here are a bunch of right triangles. And if GF is 120, that means DG is also 120. So what we have here is 2 right triangles. So I'm going to write here DG is 120. It's the same thing as GF. So if we want to find AC, first we would need to find AF. And I can use the Pythagorean theorem to do that. I can do A squared plus B squared is equal to C squared. I could use 120 as A. I'm finding the other leg. and 130 is my hypotenuse. And I just did my solving really quick over here on the side. So I squared 120 and 130. Then I subtracted 14,400 from both sides. And finally, I took the square root of both sides. And I got that the side length is 50. So AF is 50. You can use AF to then find AC. But once again, this question is more difficult than what we are going to see. I might actually remove this question, so if I end up removing it, then just ignore this part of the video. I'm going to reset so we can do 15 and 16 because these ones are actually similar to what we need to know about the angle bisectors and the incenter. It actually uses the fact that angle bisectors cut the angle in half. So I'm going to just like reset this over here. I want to keep my markings on the angles because that's going to be important, that all of the angles are cut in half into equal parts. Okay, so we know that angle ABC is 110 degrees. So that's this whole angle here. And the measure of GCF, so that's just this part of the angle here, is 20 degrees. Find angle GAF. Okay, so if this is 110 degrees, I know it's being split equally in half. So half of 110 is 55. So I'm just going to fill in what I can. This is 55 degrees. This is 55 degrees. This is 20. So this is also 20. So in the big triangle, we know three angles. We know that angle B is 110. We know angle C is 20 plus 20. That's 40. 110 plus 40 is 150. So that makes angle A 30 degrees to make the whole triangle add up to 180 degrees. We need GAF, so that's half of the whole angle. The whole angle is 30, so that is 15 degrees. Okay, let's reset so we can do the next part of the question. If measure of angle ABC, that's this whole angle here, is 4x plus 12 degrees, and GBA, where is GBA? GBA is the half of that angle, is 3x minus 4. Find GBC, so find the other half of that angle. Well, these two halves should be the same thing because we have an angle bisector here. So if this is represented as 3x minus 4, this should also be represented as 3x minus 4. So I can set up an equation that says the two 3x minus 4 parts put together should give us the whole angle because each of this is half of the whole angle. So the 3x minus 4 angle plus the other half, which is the same thing because they're equal halves, is equal to the whole angle, which is 4x plus 12. We have 6x minus 8 equals to 4x plus 12. Subtract 4x on both sides. We have 2x, and adding 8 is equal to 20. So that means x is equal to 10. So if x is 10, I'm going to plug in to find the measure of angle GBC. So that's 3 times 10, that's 30, minus 4, that's 26.